hello everyone. This video will be a little different and I will try and edit out very little from this video. So in this video we will try and solve problems with all the things that we've learned in Python so far. In this video I will try and show you the whole process of solving problems or trying to solve problems and fixing problems, trying to find bugs, the errors that you see, how to understand them. So this process is far from perfect, and I think this is the best for beginners. In fact, I still use this method when I don't really understand the errors and the problems that I'm having. Although I have a lot of knowledge about Python now than I had earlier, but I still use this method. Thank you. So let's get started. Let's look at the first question. How many times must a sheet of paper of thickness this much be folded to reach the moon? Okay, this is just this question is very simple. Thickness of paper of is equal to 0.01. 0.01 mm. Let me see. Oh, okay, no, it's 0.1. Sorry. And let's just copy this. So the moon is this much kilometers away. Distance to moon is equal to kilometers. So you see these hashtags are pound symbols. Whatever you write after them is a comment, so the Python doesn't treat them, but it makes the code easier for a person to read and understood. So as you can see that these are two different units. So if I convert this to centimeters and then from centimeters to meters, alright, and I'll convert this to meters as well. Okay, so now this is meters and this is also meters. What's the question? How many times? Okay, so how many times do we need to, okay, or just a simple way to ask the same question is how many sheets of paper must be stacked on top of each other to give us this much thickness. Alright, so this is just a simple case of division. Number of sheets is equal to, now the number of sheets is of course this divided by this. So distance to moon divided by thickness of paper. Now let's print number of sheets. Okay, now if we run this program, we should get, okay, alright, I'm sorry, I just copy pasted it. So we can use the underscore sign for us to easily read the numbers. The Python is just gonna see numbers. It's gonna ignore these underscore signs. Alright, so let's run it again. Okay, there it is. Alright, so this many sheets of paper, this many times we're gonna have to fold this paper. Okay, so one thing, one sort of function that I want to show you guys before anything, which will help us take input from the user. So for example, and it's a very simple function, and all you have to do is input and then prompt. So you're supposed to put in the prompt that you're gonna ask. Um, thickness of, I think I'm getting the spelling wrong, but it's okay. Yeah, no. Thickness of paper. All right. Enter. You know what? Let's just say enter the thickness of paper. Now, what it's gonna do is when you run this same program, it's gonna ask you this, whatever you've written here, and it says enter the thickness of paper, and I'll just say 0.003, and I'll continue. But you get the same answer. That's because the calculation is done with this and not whatever we've put here. So what I'm gonna do is put this statement, or you know what, I'll just say user input, user input is equal to this, and then instead of this I will just say user input. Now the thickness of paper is whatever you enter here. So now let's run this code again. Now if I enter 1, we should get this number. We should get this number here, because anything divided by 1 is just the same number. So now run it, press enter. Now it says that we have some kind of error in line 9. Wait. Okay, what is the error? Line 9, module number of sheets. Okay, unsupported operands, integer and string. Alright, so now what we're getting is the input that we enter here is an string by default. So what we're gonna have to do is convert this string to an integer. And how do we do that? Well, we just force it to be an integer, but in our case I'll actually force it to be a float, because of course we're gonna need more precision in the thickness of paper. So alright, now let's see if this runs. Alright, there's no error here this time. So 0.01. Okay, no, actually we're gonna do 1. Alright, so as you can see, we get the same number here as the distance of moon in meters. Alright, so I'll actually just I'll just edit the prompt here in meters. Alright, so now you can see the whole code here. We create a user input and we ask for an input from the user, and then whatever you put inside the parentheses of this input function is the prompt, is what you ask the user to input. I could say put your name, put your number, or whatever. And the input by default that the user gives us is an string. So strings are just, so this is a string, something that you would write, something that you can read. Numbers are different, like float, integers, and complex, but string is another object which is A, B, C, D, E, F, G, something that you'd read. It's not a variable. Alright, so that string we convert, we force it to be a float, and then we give whatever value we get, we assign this user input variable to it, and then we equate thickness of paper to user input, and then we do the calculation, and in the end we print the number of sheets or the number of folds, but it's essentially the same. Now let's run this code again, and then now you see I can see the in meters here, in meters that I put here. All right, so if we let's say if we give it 100 or 1000, it should just take away these 3 zeros and then give us this answer. All right, I'll just press enter. Yeah, there you go. It took away the last 3 zeros and it's given us this answer. Now you might wonder, what if you enter a string here? Let's say I enter my name here. All right, see, now it says that Harshan, which is a string, cannot be converted to a float. And the computer is right. For this, we're going to deal with errors later in the course. But for now, as it says, the thickness of the paper in meters. So we're going to have to not give it a string. Instead, we're going to have to give it a number. Let's say, yeah, there you go. So you can see how powerful this function is. Input, you can ask for inputs from the user. So now you can just so now our function is more general. So now this program that we've written, this piece of code, does not only work for thickness of this much, but it works for any thickness, any. Like I've shown you some examples here, and you can use really any thickness. Let's look at the next question. It says calculate your BMI, body mass index. All right. So and the formula is right here. Your BMI is your weight in kilograms, your height, square, and then you just divide them. The weight has to be in kilograms, and the height has to be in meters. All right. So let's use the input function again. All right. Now remember what we had to do, because whatever input the user gives is a string by default. So we're going to have to convert that string to a float. And usually height, weight, and all these things have to be converted to a float, because integer isn't very precise and will not give you exact answers. User weight divided by user height. Alright, so I always prefer to use parentheses because I think it makes the formulas more clear, and you don't really have to worry about precedence of one operator, and the other. So although I know for a fact that that exponent has more precedence than division, but of course this, just writing the formula like this, the math like this, it makes the whole thing very clear and easy to understand. Alright, so I have the BMI. I'll just print BMI now. Print BMI. Alright. Okay, now let's run this. Now it says now it says please enter your height in meters. I'll just say 2 meters. Please enter your weight. My weight is 80, so I'll just press 80. So my BMI is 20. Alright, so that's BMI. So you see how this makes our piece of code so much more general and so much more useful, because now not only I can use it, but really anyone who wants to calculate their BMI. All you have to do is run and then put your numbers or whatever, and then it'll give you a BMI. Now let's look at the last question. This is going to be a big one. I want you to solve this question on your own and not look at the solution that I will do, because of course you can check your solution with my solution, and don't worry, there is no one way of doing this question. You can do it in any way. You're not a professional, neither am I. We're gonna make stupid mistakes. It's all right. It's all part of learning. So yeah. All right, so the World Geodesic System is a set of international standards for describing the shape of Earth. All right. In the latest WGS 84 revision, the Earth's geoid is approximated to a reference ellipsoid that takes the form of an oblate spheroid. Okay, wow, so many oids, with semi-major and semi-minor axes. This is a semi-major and this is a semi-minor, respectively. Okay, use the formula to calculate the surface area of the spheroid, and then we're gonna have to apparently compare by just comparing it to, by assuming the Earth to be a sphere. All right. Okay, this isn't too much. Well, the only thing that we should be worried about is writing this formula, stupid formula. So you can see how I'm doing my comments. They actually make someone who's not familiar with what I'm doing, it'll make his or her job easier. And it could be you, because you'll hopefully write a lot of program in the future, and then when you come back to something that you wrote like a year ago and then try to do it again, like debug it, let's say, then you will realize that, oh, I'm not able to understand my own code. So it's always good to have a nice commenting game going on. So yeah, it actually makes writing code more easier as well, because my friends and including me, what we would do is actually plan and break the code, the program, and then just write comments of what we're supposed to do in this section, which I will show you these techniques in the future as we go ahead. But for now, just know that having a good commenting game is always nice, and maybe you can always get extra marks if you're looking for those extra marks. E is 1 minus c square divided by, a square. So that's the formula for E, and then we can use E here in so there is the formula right there. So I just did this here, this part here, as you can see, and always try and use these parentheses. You see how much easier they make your life. And I'll just do this part now here. I'll just import a library, math library. Import math as m. Okay. mm dot by, there you go, a square. Just I'll just try to make it as readable as possible, so it's easier for me to understand later on if I'm doing everything right or not. 1 plus plus 1 minus e square. Okay. Divided by e. Okay, yeah. Here I will have to multiply it with a tan h of e. Okay. Let me just add another. I know I'm just overdoing these parentheses, but it's actually always good to overdo them instead of not doing them at all. Into into arctan mm dot tan h right here, it's a function, and then of e. Alright, and then And then that's it. Print. You see how parentheses make your life so much easier, even when you have to type out such a stupid big formula. So yeah, use parentheses. Let's run this now. Okay. So line 8, this line, um, the error is float object is not callable. I'm not sure what you mean by this error. So this is by a square mm.10. Calculates this and then it multiplies a with it and it multiplies tan h e here. Okay, so I'm not able to understand this. Um, so what I'll do is copy this and then open Safari and then I'll just there you go. I'll just paste it here. Not callable. All right. Now let's see. So Stack Overflow is a very good website to find what type of error that you're facing. And one thing about being a noob to programming is that every error that you get, someone's already gotten it and someone's already figured out the problem. So all you have to do is Google it. When I run receiving this error, so this guy's also receiving the same error. So now let's see what are the answers. It's not something here occurs because the parenthesis and lack of operator, which could have switched the parenthesis into precedence operator. Make Python try to call the result of as a float, as a function, which is not allowed. The parentheses are not needed in this case. The calling is sufficiently correct. I think I get what they're trying to do with. So apparently I haven't, okay, right here. So what I haven't done is put a multiplication sign, and Python doesn't know if this is. So for us, it's so natural to understand that they're being multiplied. But for Python, this isn't very natural. So, and we were supposed to be defining what happens in between those parentheses, those two separate things. So now let's try and run the same code. There you go. That's what we get. I'm actually going to leave this end part for you to compare. So yeah, that's it for now, I guess.